Okay, one last thing. Let's look at using conjugates to rationalize denominators. We talked about conjugates in the last video, so if you didn't watch that, you may want to go back and look at multiplying binomials with radicals, because at the end we were talking about conjugates. So just a quick overview. Conjugates are when, let me get my pen, conjugates are when you have, and I tell you what, you don't necessarily have to have radicals. We're going to use it with radicals. Conjugates are like this. You have the same terms, opposite signs. And something beautiful happens with those every time you multiply them together. And it's so helpful when you're rationalizing denominators. Because remember, our goal when we rationalize denominators, you cannot have a radical in the denominator of a fraction. It's just not mathematically, approved of. So you've got to fix this guy. Well, using conjugates is the way out. So what you need to do, every time you see one of these that, it's written in fraction form and you're trying to leave it as an answer and put it in simplest form, this guy needs to be fixed. You can't leave square root of 2 and square root of 3 at the bottom. And you can't just use the basic rationalization techniques because you have an addition sign. This is a binomial. It's not just a monomial. So it needs a little bit more effort. Now, first of all, you don't really care what's in the top. Now, if it's just a number in the top, it sure is going to make it a lot simpler. The more cluttered the numerator gets, the more time-consuming it gets, but that's about it. Your interest lies in the denominator. What you need is this conjugate idea. You were given square root of 2 plus square root of 3. I need you to do same terms, do the opposite sign. So I need you to come in here with a minus. So square root of 2, square root of 3, and I need you to come in here with a minus. And remember our idea about rationalizing. We are not changing value. This right here, since it's the same thing in the top as it is in the bottom, this fraction that we're multiplying by, that is actually equal to 1. And when you multiply anything by a value of 1, you get what you started with. So we're not changing the value of our original fraction, but we're definitely going to change what it looks like. So, and again, when you multiply fractions, you're going to multiply straight across, okay? Now, if it helps you, you can put these in parentheses just so that you can kind of, know what's going on, if that helps. In the top, you're distributing a 1, which basically means you don't do anything. It's just square root of 2 minus square root of 3. In the bottom, you're going to have to put forth a little effort. Now, after you do a couple, you should notice a pattern. There's definitely a pattern. And you can quickly pick up on a shortcut. But let's just do the long way first. Square root of 2 times square root of 2, that means you get 2. So square root of 2 times square root of 2 is 4, or it's square root of 4, which is 2. So basically the radical comes off when you multiply. Now keep going, square root of 2 times the square root of 3, and that is negative. So let's put our little negative there. That's going to be the square root of 6. All right, go back, grab the square root of 3. Here we go. Square root of 6. Remember, outsides play together and insides play together. And then we've got the square root of 3 times the square root of 3. And we have a positive times a negative, so he's negative. But remember, if it's the same term underneath, the radical just comes off. Okay? That's when you have a square root. It doesn't work with a cube root, but it does work with a square root, because that gives you two things underneath. And that's necessary. Okay. Now, when you get to cleaning this up, it's lovely. Check it out. You have a positive square root of 6, and you have a negative square root of 6. They cancel out. That's the beauty of conjugates. No more radicals, exactly what you wanted. All you have to do is combine these terms. 2 minus 3 is a negative 1. So you could leave it like that. Probably would prefer that you clean it up a little bit. All a negative 1 is going to do, if you distribute negative 1, because you really don't even need it in fraction form over 1, do you? The negative, if you distribute it, you're going to take your binomial and turn him around. If you want to know why, think about it. Distribute negative 1. It's negative square root of 2 plus square root of 3. And most people would just take it and say, oh, let's kind of make him where the negative is sandwiched. So if you wanted to skip to straight down here, all we did is we took the terms, we turned them around, and we took the negative 1 off the bottom. So by spinning the terms around, you picked up that negative. So we just distributed the negative 1. Hopefully that didn't throw you for a loop. Okay, let's look at another one. We need our conjugate. We're just going to practice 3 or 4 of these. Conjugate is square root of 31 plus square root of 9. Stack it up. By the way, if it's doing square root of 9, can you fix that first? What is the square root of 9? Can't you do that? Let's go ahead and put us a 3 there. Right? Okay. So now, same idea as before. We're going to distribute. And if it helps to wrap these up, that's fine. But this is just 29 times everything up there. But remember the rule. Outside numbers go together and inside numbers go together. This 29 is an outside number. The square root of 31, he's an inside number. So they don't technically go together. Think about it. There's a 1 right here. It's 29 times 1. So that's 29 square root of 31. Then the 29 is actually multiplied times the 3. So 29 times 3 is 87. So plus 87. All right, in the bottom, I'm going to have, that's going to give me 31. And then if you go through and actually multiply 3 square root of 31, then you're going to have a negative 3 square root of 31. And then when you do the last two, you'll have negative 9. Okay, in the top, just copy it down. That's all you can do with the top, just copy. You've got to put your stuff together. Then notice, this is going to happen again. Then you can put your terms together. 31 minus 9 is 22. Now, you have to ask yourself when you do this, last time we had a negative 1 and we just kind of distributed and everything was great. When you get to this point, you do need to see if you can reduce. So, technically, what you're supposed to do, where the technicalities of it all, is you would need to factor the top and see if that factor reduced with the bottom. The shortcut version is check out all 3 of these terms. No inside numbers, all outside numbers. If all 3 of those reduce by the same amount, then you can reduce your fraction. I don't know of anything that goes into 29, 87, and 22. So that would be my answer. I just kind of wrote all over it, but that's my answer. Now, the only other thing I'd like to say on this problem is this. At this point, I'm hoping it has dawned on you that your middle terms over here, this one and this one, those are the ones that are giving you these repeat terms over here that cancel out every time. The only thing you need is the front, that gives you this, and the back, that gives you this. You could do without the middles. So on the next problem, I'm not going to do the middles. If that messes you up, by all means, just multiply all 4 out, and then you can go through the canceling process. So this one does look a little bit worse. This will probably be the last one that we'll do because we're kind of running out of time. You could start this problem just as an aside. You could reduce square root of 18 before you got started, but it doesn't really matter. You could go ahead and dive in. So we got square root of 18 plus 2 square root of 3. But remember, when you stack it, the fraction that you stack, everything needs to be the same because that keeps this fraction equal to 1. That's what allows you to do this thing. Now, I probably can't come over here to the side and write my problem like I've been doing. I'm going to have to come underneath here. The reason I say that is because when you look over here, my numerator just got wild, okay? That means that this is going to get long. it's going to be interesting whenever I multiply this out, because I actually have to distribute every term over here times every term over there. So here goes. It's just time consuming. It's not really hard. You just take your time. Here we go. 10 times this 1 out here, 10. Square root of 2 times square root of 18. That's going to be square root of 36. Ooh, that's interesting. Then we come over here. Remember, outsides with outsides, insides with insides. So that's going to be 10 times 2 is 20. Square root of 2 times square root of 3 is 6. All right, you're done with that guy. Get this guy. Square root of 6 times the square root of 18. I have no idea what 6 times 18 is. So that's going to be 108. All right, keep going. Now the 2 doesn't have anybody. There's a 1 out here, okay? So it's just 2, and 6 times 3 is 18. Now that's my numerator. Just don't get stressed out about it. Just leave him there. You can deal with him on the next row, okay? Now in the denominator, let's use this little, what we've learned from our other problems. We know that the middles are going to cancel. We don't have to do the middles. We need the fronts. Square root of 18 times square root of 18 is 18. And then we also need the backs. So when we do the back, that's going to be, that's always going to be negative, because you're going to have a negative and a positive. Whichever way it goes, it will be negative. Now, this one's a little bit interesting because you have a coefficient and you also have a radicand. So 2 times 2 is 4. And when you do square root of 3 times square root of 3, that's just 3. Okay? Leave it there. Nobody said you had to do everything in your head all in one step. You can write things down. So, keep processing. And if you want to just work with the numerator all the way down and then come back and work with the denominator, I don't really see where that's a problem. So, I'm going to pick it back up with the numerator. Think about it. Square root of 36, that is just 6. Okay? And then I can't do anything with the square root of 6. 108. I need to see what goes into 108. 108 divided by 9. Oops, I hit the wrong thing. He goes 12 times. There's a 4 hiding in 12, so I bet 108 is divisible by 36, because 9 times 4 is 36. Yes, it is. So here we go. I'm going to do that 36 times 3. And over here, 18, that's 9 times 2. So down at the bottom, 18 minus 12. And I'm going to scoop this up just a little bit to give myself some space. And we're going to have to wrap this up quickly. My time is running out. We've got 60. This is 20, square root of 6. The square root of 36 is 6. The 3 is left. Now, think carefully. The square root of 9 is 3. 3 comes outside and multiplies times the 2. So 2 times that 3 gives me a 6. This 2 remains inside. Now you can scan it. Every one of these is different, so nothing goes together in the top. 18 minus 12 is 6. Now, what I told you earlier about checking to see if you can reduce, look at all your coefficients. Remember your outside numbers? Now that's a constant, but he counts. What do you notice about them all? Hopefully you notice that 2 goes into every one of them. So let's divide everybody by 2. This reduces our fraction. Now technically what we've got to do, you're really taking a 2 out here. It's just that most of us don't ever write it this way. Technically you factor it and then you reduce it. And most math people don't go through that step. We do the shortcut method and we skip from here to here. If you notice all the things circled in blue are even, take all of them, divide by 2, you'll get the answer down here in brown. Well, I hope that helped.